When people typically think of the ionosphere, they just think about the aurora borealis that occurs within it, the green, red, and purple light show that frequently paints the Saskatchewan sky at night. However, the ionosphere is actually very closely tied to long-distance communication for two reasons. First of all, because the ionosphere is filled with charged particles, we can actually take radio waves and bounce signals over really long distances. We don't typically do this too much, except during disaster scenarios, such as just during Hurricane Maria, as well as during 9/11. The second reason that we use the ionosphere for long-distance communication is that we put satellites within this region. So our GPS satellites are there, our communication satellites, as well as satellite TV satellites are within this region. Therefore, our ability to characterize and understand the ionosphere is very closely tied to not just the well-being of these satellites, but also the signals and the quality of the signals that we use. This doesn't just impact our ability to maybe find the local coffee shop, for example, but it also impacts our ability to perform search and rescue missions, to locate and communicate with people in remote areas, such as the high Arctic, but it also impacts our ability to maintain our Canadian sovereignty. So one of the ways that we examine the ionosphere is we use these huge instruments called incoherent scatter radars. And what they do is they probe small amplitude irregularities within the ionosphere. However, one problem with observations from incoherent scatter radars is that the effect of strong electric fields has not been accurately fully characterized. So what I've done in my research is I've created, using plasma simulations, a database of hypothetical incoherent scatter radar observations that you would see, so that researchers can take their observations, compare it with that, and know more accurately than has ever been possible before what they are actually looking at in the sky. And so my findings have been published in Akbari et al. 2017, as well as in Goodwin et al. 2018. But the most fascinating I found isn't actually published in either of those things, which is simply that if you look 20 degrees with respect to the magnetic field, you will know instantly if you have a large electric field within that region. And so that makes synthesizing these observations a lot easier. So what I'm doing right now is I'm helping to take my database and integrate it into fitting software so that researchers don't have to hand compare their observations with my database, but rather there will be codes that just do this automatically. As well, in the next, 2 weeks, actually, it's coming up pretty close, I'm going to have defended, and then I'm going to be moving to Boston and working at Boston University to work with researchers there who work frequently with incoherent scatter radars. As well, I'm going to be working with researchers at MIT and SRI International to fully integrate my software into other software. Thank you.